Hello and welcome back to another video in my CUDA tutorial series. Today we're gonna take a colored image. Oh, exactly that image shipped within the GitHub repository. 4K image, so basically 4069 by 4069 pixels. And we're gonna take this image here and we're gonna convert it to grayscale. Well, how is it done? I don't know. Let's ask Google. Now let's get a tab here and say color image to gray scale, which I mistyped, but you can find an article on Wikipedia. So grayscale, and we should also find this formula here. So this equation here, y linear equals 0.2126 r for red, plus 0.7152 green, plus 0.0722 of blue. So basically we want to take that formula and apply it to each pixel. Yeah, let's get started. Issue. This is a PNG. How do we open such shit? Well, let's Google this as well. So C++ open PNG. Oh, how to open and modify PNG. Actually, I know how to do it, but I want to have that somebody is telling us that we're gonna need this. Why are they not suggesting the most easy library? Alright, so we're gonna use STB here. STB image. STB is a single file header that does stuff. STB in general are single file headers, so nothing's STB, single file headers, and we have STB image for image loading, and we have STB image write for image writing. We're gonna need both because we want to also spill out the grayscale image. So these two ones, we need them. Oh, it's actually the ImGui guy that has contributed to this library as well. That's amazing. Raw, I want raw. View raw. That's what I want. And again here, view raw. So now we have these two files, SCV image, Control A, Control C, go to project, and add a new item, a header. Taking ages. So we want to have a header, stb underscore image.h, and then Control A, Control V for pasting stuff in here, and I have caps on. No, I don't want to have caps. Now we have this amazing library in here, which is big, but basically this library doesn't come with an implementation. You need to implement this by yourself. No, not that you need to write it. The implementation is inside the header, but it's by default not invoked, so we need to do this. And somewhere down here I should find the include, which should come after this block. Yeah, there we have it, stb image implementation. Copy that. Then I wanna create a file. I still need to set up the shortkeys for Visual Assist. So then we're gonna create another file, stbimage.cpp, and we're basically gonna say hashtag define that constant to implement it. And because this sometimes screws stb up, let's include Windows here. I don't know which stb library that was, but one of the stb libraries did had some issues because it tried to use the unsafe CRT functions and whatever, and basically including Windows did set up the proper preprocessor constants that made this tick the right way. But what we definitely want to do is we don't want to include Windows because this should be cross-platform, this tutorial, or should it be? We have a solution included. Yeah, if we are on Linux, just get rid of this line. You can do this. I believe in you. Alright, so yeah. This basically compiles as SCB image in here. And the nice thing is it already comes with the licenses, and it's also available under the unlicensed, which means that we don't need to care about shit. Alright, so let's also get SCP image right, copy again, and we're gonna do the same one again. Come on, create file. There's a CUDA file that doesn't like CUDA. Yeah, there was something with Visual Assist that it doesn't like CUDA. So let's create the file the proper way. stb image write.h, Control A, Control V, go up somewhere here probably. there it is, STB image write implementation, quick actions, create file, C++ file. Let's do the same thing again here. Let's define that and let's include Windows. Windows.h so that everything is good, and basically what we have is we have STB included. So I'm gonna hope that this compiles, but I don't know why it shouldn't. Let's see. Yes, it compiled STB image. And it's still complaining that it has used one unsafe function, but it's not a issue here. Is it an error or is it a warning? I think it's just a warning that we got. It's still a bit interesting because actually it should use that one. C like STB, STD, C lib x1. This should automatically make that one used. But it's not doing that. But yeah. Maybe because sprintfs on Microsoft needs the size on the back, whatever. But it's compiling, so we are good. It's probably defining the constants itself that it needs to compile, but it compiled, so I don't care. All right, so now we have STB in here, and now what we want to do is we want to open a PNG and we want to directly store it back again. Good. Yeah, that's what I want to do. So let's include this. So let's include STB image and image write like that. Now we have STB in here. So STB I open PNG, or what is it called? Load from file. Yeah, load from file. So we need a file pointer. No, I want to have a file name. Does it work also with a file name? Let's see. I haven't used STB image for long. I always use the Windows imaging component, which is like total madness to get. But the nice thing is STB is documented inside the header itself. So we should have, yeah, STB load F. Load F. All right. Yeah. Okay. Yeah. If you think that is correct, then we're gonna use it. No, I want to have the default one. This looks too. There we have it. That one. I want to have that one. That default one. That. Here we are. Good. So basically that. We want to have that here. So basically that one. Unsigned char, pointer, data, STB, I load, file name, whatever. Good. So let's put this in here. File name's gonna get something like that. Then we're gonna have some size t's, width and height of the image. And we have the component count of the image. So we're gonna poke in width, we're gonna poke in height, we're gonna poke in component count. And are you using normal ints or what? You're using normal ints, right? If you want to have normal ints, you're gonna get normal ints. So we're gonna open the image here. So we're gonna have a file name in here. Let's actually put this as an argument. Argc char pointer argv, and we're gonna check. First of all, let's do this the dirty way. Check argument count. So if argc bigger or smaller than 2, we're gonna do an std cout usage. How did I call this? 0 to image to gray file name like that. STB handle returns -1 because we encountered an issue. So this checks the argument count. Now we want to open up the image. We're gonna do proper error checking, by the way, from now on. So we're gonna take the first argument because this is the second argument with the index of 1, because the first argument is basically our path where we are currently executing. The 0 is component count. I want to force this component count to 4 because I want to use 4 components. Like this is then properly aligned for the GPU and stuff. So we're going to use 4 to force this count. And we're going to now see if we're going to check if the image has been opened. So if we don't have any data here, or let's call this image data. So if we don't have any image data here, we're gonna say std cout failed to open argv1 because that basically failed. And also let me get rid of the std handle because it's gonna handle anyways if we're gonna return. This is gonna look a bit better. So we're gonna do this like that. So right, now we have opened the image. Now we want to validate that our image works. So validate image sizes. Because, now comes the big because, later on when we are going to GPU, we're gonna compute our images on a 32 by 32 pixel block base, which makes 1024, which is the maximum size. I'm not gonna care if this is optimal for the GPU or not. We just want to have a simple example, and this means that our image size needs to be divisible by 32. So I'm gonna check if with modulo 32 or height modulo 32. So this always needs to be return 0, both of them. So if one of them does not return 0, we're gonna have an issue. And I'm gonna say width or height is width and or height is not dividable by 32. Alright, like, I don't care about STBI not cleaning up memory correctly, because, well, who cares? Because it's gonna be cleaned up at the end of the application. I'm gonna rely on that one. It's not 100% nice like I'm doing this. You should do this if you are using some productive environment. You do this better. Yeah, so basically I'm gonna do a note here, leaked image data. So just that you're aware of that I have leaked the memory of image data, basically that I have leaked it. But let's actually now close the image here. So SCBI 3, I think, was it 3? No, image 3. Image 3, and we want to image 3 the image data, so free memory, basically like that. And somewhere down here I also want to write image back to disk. And I just want to append the gray to that. And how do we want to do this appending? Well, we're going to make the use of std string here. Hashtag include string. Write image back to disk. So basically here we're going to build the output file name. And I'm going to do this by std string file name out, and this is going to be equal to argv@1. So I'm just going to take the input file name. Now I'm going to take this out one, and I'm going to do a substring out of that. So the offset will be 0, and we're going to start counting somewhere. And we're going to start count at find first off, and we're going to find, oh, actually we want to find last off. I'm an idiot. Find last off, and we want to find the last point. Then we're going to substring out of that, and the question is it returning a new string? It's returning a new string. So file name out is equal to that plus .png. Yeah, that's what I want to have. So I'm going to build this output file name here, and is it actually, if I go to count, it's gonna give me the, I might need to go -1 or remove the dot here. I think I need to remove the dot, but we're gonna see later. Alright, SCBI write. So now I want to write the image out again, write PNG. And now I want to write to file name out.cstring. The width and height still stays the same. Components are still 4 because we forced it. We're gonna go image data, and the stride gonna be 4 times the width, because 1 pixel is 1 byte back, and so the stride should be good. If this is gonna return me an int. What is it? Is it returning? Is it returning? What is the return value? Usage. Aha. Do I find something? Is there, I don't care, I'm not going to check for errors here, we're going to see if the image is being produced or not. Alright, this code now should write, I'm going to make a breakpoint here to assert that everything works. This code should just spill out the PNG that we had just read it, but if we're going to start it, we're going to get some issues. Because we haven't added a image name to the command line arguments, it's going to say usage image to gray file name. And to do this, we're going to go to properties of our project, we're going to go to debugging, all configurations selected, it's important. And we're going to add a command line arguments, our image will be an image slash, how did I call this? Ship underscore 4K underscore what.png? How did I call this? RGBA ship underscore 4K RGBA.png. And this should now give us our image. Let's maybe do a breakpoint before that as well. And if you now start this, it failed to open the image even though I made a breakpoint here. That's interesting. Are we on a release? That's not good. All right, so we are on debug now. And let's see. I wanna maybe see what my arc v1 is. It's not getting this. Can I go to auto image? How did I call this images? Yes, I called the folder images, so there is my issue. I need to call this images and not image, which makes kind of like sense because there are gonna be multiple ones in here. So images, ship 4K, RGB, whatever. So yeah, let's start this again. And we are getting to that, and we can see, the dot is still required. I'm like sometimes confused with these substring stuff because I don't use them quite frequently. I normally like to write state machines if I'm doing string processing because state machines are good, amazing, nice, good, whatever. But yeah, let's restart this and see if what we get now. We should get now a proper output, a string name of and I also need to also append the gray here, of course. If I'm not doing this, I'm going to overwrite. That is why I have my breakpoint here, that I not screw up everything. You can see it's taking quite a long time to load this image because it's actually quite much data to load. We have like 124 megabytes of RAM that we use. All right, RGBA gray.png. And if I would now click continue, it's going to take again because it needs to compress the image. Is compressing really taking that long time? Oh, damn. Yeah, but it finished, and let's see. Let's take a look at the directory, and we have an image that is called gray, but it's not gray because we haven't done any image processing on it. So basically now we have two identical images, one loaded and one stored, and now we are ready to process it. So yeah. Process image. All right. Let me just add a bit of debugging output. stdc out, loading PNG file. And then I might do I want to do an std end line here in case this failed. And here we're gonna say just a little done. And an std end line to make this formatted like I like it to have. There we are. Good. Now we're gonna say here, down here, you're gonna say writing PNG to disk. And then we don't care because the application will directly terminate after that. All right, writing PNG to disk. Writing. There we go. PNG to disk. That's what we want to have here. All right. So now we need to process this image, and let's start by processing this on the CPU. So void convert image to gray CPU, and we're gonna have as an argument a const, or not a const char pointer image RGBA, and we're gonna have a int width, and we're gonna have an int height like that. And then we can now do some stuff. What are we gonna do here? So we're gonna write two for loops for int y equals 0, y smaller height, y plus plus, if you could spell height correctly, for int x equals 0, x smaller, width x plus plus. And now we need to convert something, so let's maybe first define a pixel. So we're gonna do a struct pixel, and the struct pixel is gonna contain a unsigned char RGBA like that. Actually, I'm not quite sure if stb is actually returning me RGB or is it BGR. I'm not quite sure how it's doing that, but I think let's maybe consider that. What for components mean. There is a chart in here that shows what components mean what. RGBA. Alright, 4 is RGBA, so we are good. Alright. So RGBA, that's basically our pixel, and what I'm gonna do is I'm gonna create myself a pixel pointer, a pointer pixel, and this is gonna be equal to We're gonna take our image RGBA and we're gonna offset. We're gonna take the height, the y coordinate, times the width times 4 plus 4 times x. This should give us a proper offset, and then we can convert this to a pixel. And now inside of this pointer pixel, we can basically say, let's do a float pixel value, which is going to be equal to pointer pixel dot r times. Now I need the equation that we had. Where do I have it? Grayscale. Let me put this on a separate monitor so that I can see this. So r times 0.2126 float. No, there's a float. Okay, good. Right, no, not like that. And then we're gonna add something on top of that. So pointer pixel rg times 0.7152 float plus pointer pixel RGB times 0.0722 float. Done. And what we then want to just do is we want to say pointer or char or unsigned char pixel value, or we could just like unsigned char this one here, make this in a big bracket and convert this to an unsigned unsigned char like that, and this should properly convert this to a pixel value. And then we're just gonna say pointer pixel r equals pixel value rg, and just for the sake of killing the opacity, we're just gonna set the alpha value to 255. Good. This should convert our full image to grayscale. First we're gonna calculate the value, and then we're gonna set all pixels to that value, because we are gonna just set all values to the same, and this basically means that we don't have any color. If all color values are by the same, we are in a grayscale. I mean, there are grayscale pixel images, but no. It's easier to do this like that, and we can use the same memory buffer to operate on, and we don't need separate memory buffers. It's just a bit simpler. All right, so let's do a little cout. So processing image, point, done. SCD cout, done. SCD endline. All right, and now here we need to invoke this function here. Let's get this down here, and we're gonna input our image data. We're gonna input our width, and we're gonna input our height. And is it what? Was I? Oh, all right. So SCP is actually taking unsigned chars. Good. All right. Or outputting unsigned chars. Good. There we are. Let's see. Not to do. Process image on a CPU. Let's see how this performs. I mean, we don't have any measurements in here, but it's gonna take some time. All right. Loading PNG file, loading, done, processing image, and now we can wait. Because our CPU is crunching data. Ah, we have an issue. Why do we have an issue? Ah, yeah, of course I need to get the pointer, not the raw value. I'm an idiot. So adding this pointer here should solve stuff. And let's see how this is performing now. Some issue. So loading PNG file, done. Processing the image, done. Why is it so fast? I wanted to finally have an application that runs on CUDA faster, but it's not. It's still too fast. The CPU is bunch too fast. Like, it's like SCP is taking longer time than our processing. It's like bad. I mean, we're gonna do this anyways. I forgot the done here. SCP cout, done. I mean, I mean, at some point we're gonna have something that is faster on the GPU, but yeah, it's too fast for my taste. Like, why is SCP taking so long? It would be like more nice to implement SCP in our own code instead of our image conversion. But yeah, and if we now take a look, we have a grayscale image. Yay, amazing. So color, grayscale, color, grayscale, color, grayscale. Good. Works on the CPU side. Let's do this on the GPU. Even through, like, it's probably gonna be like taking longer again on the GPU because it's so fast on the CPU. Why is the CPU so fast? Ah, that's an issue. But yeah, let's write a nice little GPU function. So global convert gray G GPU. There we go. There we have our nice little function. We need a void, of course. So void convert unsigned char image RGBA. There we go. Now we have our signature. We don't need a width and height because like GPU work differently. We know that. So we had the same the formula that we're gonna use now. We already had this on the CPU side. I'm gonna use UN32T here because the GPU is a 32-bit processor using size T. Might be automatically 32-bit if it is in the CUDA stuff, but I'm not quite sure. So we're gonna make this explicitly UN32. So I'm gonna have an X coordinate and I'm gonna have an Y coordinate here. So X and Y for the image. So how do we get this? So we're gonna use our block index here, the block index X times the block dimension X plus our thread index X. And now we're gonna copy this line over and we're gonna also use Y. So now we are gonna go on Y coordinate. So basically we are using blocks to specify the coordinates, but since we are currently not using a proper pixel object on the GPU, I'm gonna also compute an index here, and this index is gonna be equal to Y times block dimension X times grid dimension X plus X, like that, and this should give us a proper index. We're gonna get rid of this in the next video when we're gonna try to use some CUDA image objects, but basically for now we are computing this index. Later on, if we are using a proper image object, then this can be eliminated, this computation here. Right, so we're gonna do that one. Now instead of that, we're gonna import the index and we're gonna have this as that value, and this should be good. I hope this is gonna be CUDA compatible, but I think so. I haven't tested this actually before. I'm doing this all live on video, but yeah. I don't know why it shouldn't work. Gonna see, but we're gonna see. You should never say never. Yeah, so let's maybe comment this out. Last time I have deleted the block, but you might be interested in that one as well. So now process image on GPU. SDDC out, something, or running CUDA kernel, like that. Let's write it like that. So we're gonna do this like that, and then we're gonna invoke the kernel here. Yeah, you need to do some IntelliSense here. I know. IntelliSense is so important. Yeah, but basically what we need to do before is we need to copy data to the GPU. So we're gonna have a unsigned char pointer image data GPU pointer image data GPU. Then we're gonna say CUDA malloc, and I'm gonna CUDA malloc the pointer image data GPU, and the size is gonna be width times height, which means the number of pixels times 4. And this should allocate us our CUDA memory. And we're gonna assert that. We're gonna use assertions here for now. C assert. Or are we gonna still do this like the same dirty way? No, we're gonna not do this the same dirty way. And assert this is CUDA. Okay, is there CUDA, okay. CUDA error. CUDA error, okay. Or CUDA error no, or CUDA no error. Let's peek the definition here. CUDA success, it's called CUDA success, alright, so assert probably this is defined like that, yeah. So we're gonna assert that this is CUDA success. And then we're gonna assert CUDA memcpi. Destination is our pointer image data GPU, source is our image data, size is width times height times 4 CUDA memcopy memcpi host to device, and this is going to be equal to CUDA success as well. CUDA success, like that. Alright, so basically this should give us our data on the GPU, and then we can Input this data here. Now we need to basically compute our block sizes. So actually there's like this dim3, this is like the CUDA type that we can use from now on. So we're gonna use the dim3, gonna use the block size, and the block size is gonna be 32 times 32. And then we have another dim3 is the grid size, and the grid size like that. And the grid size is going to be the block size x, or the width divided by block size x. I think this is this xy. For x for y up. Yeah. So we're going to divide the x, the width by the block size x, and we're also going to divide the height by the block size y. And now we can basically invoke our CUDA by the block size and the grid size here. Basically first, how big is the block? No, wrong, differently. Grid size and then block size. So the grid size, block size, alright, invoke running CUDA kernel, std cout, done. std end line, like that. I'm gonna have something here, so copy data to GPU. Then we're gonna have it done here as well. Let's also add a CUDA 3 here, by the way. So pointer, image data GPU, like that. And now we're gonna copy data from the GPU. So we're gonna say std cout, copy data from GPU. Just steal this mem copy here. I'm gonna swap this around. We're gonna have device to host. Grab another done here. And this should be it. So let's first delete the grayscale image because I wanna see that I get 100% the new output. And let's see if this runs out of the box. I hope so. At least it compiles, that's a good thing. We are getting some dones, this is also good. It's always good when we see done, right? Now the SCB is taking some time. Oh, we are using a 0.5 GB of memory. That's good. All right. Let's see. Aha. So there is something not working. This is not what we should get. So now comes the debugging part. You might have already spotted what's wrong there. And to be honest, it took me way too long to find it out. What was the issue? Well, taking a look at this index. Yes, it is an index, but it is an index in pixel, not in bytes. So what we need to do is we need to multiply the index in here, and I am an idiot and have already replaced some code to check if there is anything wrong with using like this type. So just ignore that. I forgot to RGB this back in. RGB, right, now we're good. So yeah, basically we have made the issue. This index that we have just created is an index that is pointing to a pixel and not to a byte. But each pixel has like 4 bytes, and if you multiply them in here by finding the pixel pointer, we should be good. Let's test this out. Just for records, I have now image output here. And let's see what happens if this is running and not showing up. Amazing. It's running, it's taking its time, it's already finished CUDAing. Now we got the picture. And you can see it already looks good. If we tap onto it, grayscale, color, grayscale, color, grayscale, color, grayscale. So yeah, we have archived what we want. We transferred an image to grayscale and was already like questioning my CUDA knowledge, since I'm also quite new to CUDA programming, but nah, it was just some silly idea of forgetting a factor of 4 here. Which should retro perspective be quite obvious, because the image was like covering, because like the previous output image was just covering a quarter. And so this should have been like predictable, but yeah, I haven't predicted it that fast. But I found it, and that's the thing. You should never ever stop trying, because most of the time it's just a simple stupid issue like that, forgetting the factor 4. So yeah, now we have written ourselves a nice grayscale image with CUDA. Total overkill, but yeah. It's a point to learn CUDA, yes? Right, yeah, true. So yeah, thank you for watching. See you in the next video. Make sure to like and subscribe, and have a nice day. Bye.